Okay, so welcome to the Learn PLC in a Day session 1, which is wiring the PLC. In this session, we are going to learn about how to wire a PLC. Now, when we are going to install a PLC in any panel or in any machine or in any process, first we have to wire up that. So we'll understand that how to wire a PLC, which wires to be connected where. So very quickly, let's understand the basic components of PLC. Now, in front of the screen, you can see this is a PLC by the company Delta Electronics, and we have some input terminals. Now these are the terminals onto which we'll be connecting the inputs. Now what are the inputs? Inputs can be switches, it can be sensors, it can be limit switch, it can be any source of inputs, and it can be any sensor. Then we have the output terminals. You can see here, these are the output terminals onto which we'll be connecting the outputs. Now what outputs and what input can be in any machine depending on the various processes. For example, suppose you're going in a lift. Now what you do, you push a button. That button is your input. That button tells the machine, tells the process or tells the lift which floor you want to get into. So that movement of the lift is to the motor. And that is your output. So you understand that button is the input which will be connected to input terminals, and the motor will be connected to the output terminals. But what happens inside that is the program, how that controller has been programmed. Similar way, we will program this PLC using this programming cable. Now, that's the programming cable. We have to make a program in the computer, then we have to download that into this PLC, which will remain stored in that. So it's all about programmable logic controller. That's what PLC stands for. Programmable logic controller. A controller which can be programmed using various logics. Logics can be if, else, or, and, not. So that's the logic which we are using in our day-to-day life. The similar logic we can program in a PLC. Now let's see for the components. We have RS485 terminals over here. Now this terminal is used to connect this PLC to an HMI or any other communication source so that we can communicate what's happening inside a PLC. Then we have D2A card. This is digital to analog card, which converts digital data into analog signals. Now in this case, digital data can be binary bits. These binary bits can be converted into analog voltage, which can be further used to drive different analog outputs. Then we have A to D card, which is analog to digital conversion, which converts analog to digital signals. Now analog signal can be given by some analog sensors. Now if you are from instrumentation, electronics or electrical background, so you can understand there are two basic control signals, which is 0 to 10 volt and 4 to 20 milliampere. So there are sensors which gives these control signals. So that signals needs to be processed, and to process those signals we have to convert that into digital form, which makes the processing very easy. That's why we convert analog signal into digital using this card. So these are the basic elements you may find in many different companies of PLC. So I'll show you another PLC that is of a company Siemens, by the code S7200CN. Now similarly here we have this is the power 24 voltage VDC which will be used to run a PLC. Then we have input terminals as we have in Delta. These are the output terminals. Then we have this programming cable which is used to program a PLC. And then a small battery. Now this battery is used to store the information, to store the program when there is in case of power failure. Now another PLC of the company Allen Bradley, Micrologix 1000 is a code. Similarly we have input terminals here, output terminals here, and again programming cable to program a PLC. Then the power of 24 VDC which is used to run a PLC. Now you can see some indications here. The PLC is on, you can see some green light. When it is run, you will see green light again. When it is having some fault, there will be some orange light over here. And when there is force input in which we are driving the input, we are running the input from inside the software instead of switches, then there will be a force light here. So these are the basic components of what PLC is all about. Okay, so this is the software in which we are going to learn about how to wire a PLC. This software is Automation Studio by the company Famic Technologies, which is in Canada, and this software is being used in our academy to teach the students how to do the wiring, how to do the electrical wiring, and how to make a sophisticated circuits, and how to test that, how to simulate that, so that after making circuits in this software we implemented them practically. So let's take some PLC cards. This is my PLC input card. It is analogous to that input terminals which you have seen in that presentation. So let's take some power sources. Now this PLC I assume is running on 24 voltage. So I'll take 24 volt and I'll take 0 volt. Now as this is the software, this PLC no need to connect some power sources. These will be connected by internally by the software. But we have to provide voltage to drive the inputs. So first understand how this input will be run, how they will indicate that there is some voltage or there is some physical activity outside this PLC. So you can see some common terminal here. Now I am going to connect this 0 volt to this common. Like this. So my 0 volt has been connected to common. Now you have to understand that we need to create a potential difference of 24 volt across these input terminals. Then only this PLC will recognize that there is some input. For example, if I connect this 24 over here and then I'm going to simulate that, you will see this is on. This is on because this 24 volt and the 0 volt. This 0 volt is connected internally to this input. So we have created a potential difference of 24 volt. Now let me clear you how to clear this understanding. Let's take a relay. For example, I'll take a coil, this one. Let's name it R0. Alright, so let's take another voltage source, 24 volt, and this one. Now this is my relay, this is my electromagnetic relay. What happens when I provide a signal of 24 and 0 across its two terminal? You will see it is on. The similar way, these are the internal relays of a PLC. You need to provide 24 volt potential difference across every element, every terminal to make it on. So if I take another relay like this, let's name it R1, and I connect this with this and this. Okay, let's not connect it initially. Now you see, this relay is getting 24 volt potential difference. This is on and this is open from one end. Similar way, these all are open from one end. They are getting 0 volt from here, like this relay is getting from here, but 24 volt is not provided. So when I provide this 24 volt, this relay will be on. You can see here, the similar way, if I connect other terminals to 24 volt, this will be on. You can see here. So the concept is we need to maintain a potential difference of 24 volt across this input and the common. Now in many PLC, instead of 24 volt, you may find line and neutral, because that depends on the manufacturer, whether he is providing 24 volt DC volt inputs or you are providing AC volts. In some PLC, you may find instead of 24 and 0, it is written live and neutral. So in that case, you have to give live over here, L1, and instead of 0, you have to give neutral. So this can be in case of some different PLC. So we have to check it out on the PLC whether it is DC voltage driven or AC voltage driven. So let's remove it out for a second. Now this was my input card. I'm going to connect some input switches here. Now this is my push button. Let's take it X0. Now I've connected this to IN0, and again I need some power sources. Let's say 24 volts. Okay, so what happens if I don't connect 0 volt over here? Nothing gonna happen. It's not going to get on because there is no potential difference. There is nothing at the common end. So we have to connect 0 volt as well. Okay, so now I've connected a switch. What happened, this is a normally push button, which is a spring loaded. When I press the switch, input will be on. When I release it, input will be off. So this is an input switch. You may find such kind of switches in your panels, in some other machines. You may find some green buttons. So this button is connected in this way. It is connected to some inputs, and then common is giving some 0 volt. So similarly, let's connect some other switches. this is my normally close button, as its symbol indicates that it is passing the signal in normal position. That is why it is called normally close, because the switch is closed normally. When I press this button, it will be open, and it is again spring loaded. When I release this button, it will be closed again. And this is normally open. Normally open means when I'm not pressing this button, the circuit will be open. So when I press this button, it will be closed. So these are the different types of switches which we can find in the inputs. Now let's have a toggle switch. Let's name it X2. Let's connect it to IN2, and then again this to 24 volt. Some more input buttons. These are again normally open toggle switch. Now this toggle means they are not spring loaded. They are retentive. They have retentive position. When it is open, it is open. When I close it, it will remain closed. So that's the beauty of the switch. So I have connected 4 switches. Now I hope you have understand that this is on because this 24 volt is already across this terminal IN1. This will be on when I press this button, and again similarly with these cases. So this is my input section, how we are getting the inputs from the outer world and how this PLC is judging the inputs just by this voltage. Again, where you're going to have potential difference, that input will be on. So this was about the input card of a PLC, or you can say input terminals of a PLC. Now let's see what happens at the output terminals. For that, I'm going to have this output card from here. You can see like this. Okay. So I'm placing this output card a little bit away from that to make the concept pretty easy. Similarly, we have different outputs, out 0, 1, 2, 3, 4 up to 7, then we have a common output. Now similarly, I'm going to connect this 0 volt. I can take the wire from here to this common output. Now here I'll be connecting the output components, not the switches, but the output components. So let's see what we have in output components. We have coils, LED display, coil unlatch, latch, solenoid, indicators. So let's take an indicator. Now this indicator is my light, so let's name it Y0. This is an indicator light. I'm going to connect the one end of this indicator to this out 0. Now I have to give 24 volt to this other end, again to maintain the potential difference. Now what happened here is, now when I simulate that, this 24 volt is traveled to the one end and another end is not connected to this 0 volt. Why? Because in this case it was already connected here, but in this case it is not connected, and this will be connected only after we do the programming. It won't run when I press this button or when I press this button or this button, but how it will run, that depends on the program. So this is my output, not running right now. Let's have some more outputs here. Let's call it Y1. Enter. So I have connected 2 outputs now. Both are not running because I haven't programmed the PLC. Now what does a program do? Program will link this input section with the output section. Suppose I want, by pressing this button, this first light should be on. I have to make program according to that. But if I want to, after pressing this button, I want both outputs should be on, then I have to change the program. I don't have to change the wiring. I have to just change the program. Similarly, if I want that by pressing this button, both should be on, I have to change the program only. Wiring is one time. Remember these. So this is all about the wiring, how we have to wire the input section, how we have to wire the output section. We can similarly connect some more inputs. We can connect some more outputs like this. So you can see here now I have connected 6 outputs to the output section and few inputs to the input section. Now in next session we are going to see how to make a program, how to make this outputs glow by using the programming. We are going to see how to do the programming. It's based on simple logics, or and not, if else not, timers, counter. So it's very interesting. Stay tuned, and if you have any doubts, kindly post below this video. If you have any doubts, I'll clear it out. So this was all about the wiring.